Hey, hello there. This is chapter 1 of the Basic Practice of Statistics of the ninth edition. And in this chapter, we talk about some of the terminology that we will use throughout the course, such as individuals and variables and what those are, categorical variables, that's when we use pie charts and bar graphs, quantitative variables, that's when we use histograms, interpreting histograms, what do they mean? What can we get from those? What kind of findings can we interpret and get from those graphs? And also quantitative variables for stem plots, although that will not be directly tested in this course, but you will see stem plots here and there throughout the course in the course textbook, but you won't be directly tested on the stem plots. A stem plot is essentially a histogram, but just turned on its side. And we will also look at time plots. Okay, so we look at these plots, and first we will just define what statistics is. So statistics is the science of data. So important today because we have so much data and we need to know how to deal with it. We can get a lot of information from it and analyze all sorts of things to make our lives better. So we have in data sets, we have what is called an individual, and that is an object. It can be a person, it could be cars, which is described by a set of data. And then the variables is the characteristic of the individual. So if we're talking about cars, we could have the variable color. We could have another variable that describes cars, let's say the horsepower, the number of cylinders, the miles per gallon, and so on and so forth. So lots of different variables could be used to describe the cars. So as an example, the individual could be cars, and as an example for the variable, there's all sorts of variables that would describe the cars. So it's a characteristic of the individual. Now, this is showing Excel, and Excel sheets are not used in the course, but you will see them throughout the book. And if you want to use them, you're free to. We will not be testing with Excel, but Excel sheets are great. They are spreadsheets, and they are a way to organize the data. But again, we won't be using those directly in this course, but you may see them and find them useful in other courses. Okay, so this is talking about planning a study, getting organized. Um, you want to ask what are the individuals, how many variables are in the data set, what's the unit of measurement? Are they doing, miles per gallon, or are they using kilometers? Where was it done? Is it Canada? Is it Ontario? Is it London? Is it somewhere else around the world? When, same thing. When did it take place? Was it in 1950 or was it in 2025? And why? What was the purpose of the collection of the data? Right. So this is basically just planning out the study and getting organized. This is what we are mostly interested in, though. Once that data has been collected, we want to know what type of data each variable is for those individuals. So we have two types in this course. We have the categorical variable, which places individuals into different groups. So if we go back to the cars example, if we have cars and the variable is color, then you could have the number of cars that are silver, the number of cars that are brown, the number of cars that are white, the number of cars that are red, and so forth. So you would be placing, it's like count data. So you would be putting each car into a category of color. Quantitative variable would be, let's say, the miles per gallon of the car. So how far can the car go based on how much fuel it has, or how many miles per gallon it can go. So they take on numerical values, but they are measurable. They're not just numbers; they're measurable. So, for example, age and it's showing their age, and also now it's showing an example here from from an Excel sheet, the sex. So they're giving the categories a number. They're saying males are 1, let's say, or females, and the other one is 2, and so forth. So you can put numbers, like we could, let's say we had colors, silver, brown, white. You could say silver is 1, brown is 2, and white is 3, and so forth. So you can assign numbers to the categories, but that doesn't make them a quantitative variable. That still keeps them as categorical variables. Whereas quantitative variable is something like age or height, something that you can capture and calculate the average. So that's what we want to do when we get a data set, is to decide whether we have a categorical variable or a quantitative variable, and we look at each variable in the data set, whether it's in an Excel sheet or just on a regular Word doc, and we want to analyze each one, because it's really important to know what type of graph you're going to use to analyze these variables. For example, categorical variables, we use pie charts, we're going to see in a moment, and also bar graphs. Whereas the quantitative variable, we use the gold standard, which is the histogram. Okay, now as soon as we get a data set, the first thing I do is conduct an exploratory data analysis. So I look at each variable one at a time, and then I plot the data. And I also do numerical summaries, which is in chapter 2. We'll look at that. And when we do this, we can then have the distribution of a variable. It can tell us so much. Are the values spread out? Is there more in one category than the other? And if so, how much? And so on and so forth. When it's a quantitative variable, we can get the shape of the histogram. We can see if there's any outliers. We can see if it's skewed or is it symmetric, and so on. So for categorical data, we want to use pie charts or the bar graph. Now, pie charts are only good if you have a small number of categories. If there's a lot of categories, it will be too confusing and you really won't get a lot of information. It's better to use the bar graph in almost every time you have a categorical variable. The pie charts, for example, on the next sheet, if you look at the health professions and engineering, if you just look at the pie chart and pretend just for a moment you can't see that table of values, you can see that you cannot tell the difference between those pie charts and who has more. This is 1.5 million full-time first-year students and what they're planning to study. And is there more planning to study health professions, or is there more planning to study engineering? And we can't tell from the pie chart alone. So it's really difficult to know. Plus, if you're using a pie chart, you need all of the data. You need all of the categories. If you're missing a category, then you don't have a pie. You'll be missing a piece of the pie. So those are disadvantages of the pie chart. And you can see I've circled 11.7 for the health professions and 11.5 for engineering. You can see then, obviously, numerically, that there is a difference. There's more health profession students than engineering, but you could never get that from the pie chart alone. It would be hard. So instead, much better to have the bar graph. And you can see here I've underlined engineering and health profession. And you can see there that the health profession is the bar is just a little bit taller than the engineering. If you look at the height of the bar, just by a little bit, right? 0.2. And this could be cleaned up a little bit more. We could go from largest to smallest. So high percent to smallest percent, or vice versa, smallest to largest, just to visually make it easier to see who has the most or who has the least. And then you can compare them. So The bar graph is the best graph to use for categorical variables. Here is from largest to smallest for a different data set. This is using Americans aged 12 to 34 years, what they use to keep up to date and learn about music. So Spotify is number 1, right? And the Google Play is the least number. So that's the percentages. Percentage for Spotify is 46%. And these percentages may or may not add up to 100%. Just from rounding by, depending on the number of data, you might be off by, it might be off by 1 or 2%, which is fine. That's okay. It sometimes happens. That's what's saying here. They don't necessarily add to 100. Now, quantitative data, we want the histogram. It will show you the distribution. It will show you how spread out the data is or how close together the data is. And the height of each bar represents the number of individuals and who take on a particular class. So we put each variable into a class or a bin, and then we construct the histogram as such. I'll show you that on the next slide. Stem plots is basically the same as histograms. It's identical, but it's just they've been tilted onto their side. You can check them out in the book, even though we won't be testing them. Okay, so the histograms are great for large data sets. You divide the values into classes or bins that I've written here of equal widths, and then you just count how many observations fall into each of those bins. And we can also change them to percentages if we want. And then we draw the picture. That's the bar heights equivalent to the number or the percent of observations in each interval. And you can see it's a continuous number line. That's the main difference here is we have a continuous number line, whereas in the bar graph, there's spaces in between those categories. We don't have that here for the histogram. So that is one way to know for sure you're dealing with a histogram is there's no spaces between because it's a continuous number line. So for our first class, we have 70.0 to 72.5. And I've circled here, we have 1 state. So this is the number of states. That's the vertical. That's the height of those classes or bins. Corresponding to, on the horizontal, the percentage of on-time high school graduates. And you could see we have 1 in bin 1, 1 in bin 2, 1 in bin 3, then 6 states in bin 4, 5, 10, 11, 14, 2, for a total of 51 states. And so from there, we could calculate what is the percentage of states that are less than 80%, right about here. Well, we just take 6, 1, 1, 1, so that's this bin, this bin, this bin, this bin, and we add them up and we get 9. Well, if the total is 51, we just go 9 divide by 51, plug that into our pocket calculator, and we get 0.176. And we can convert that to a percentage, and we get 17.6%. And that is useful because you can go, well, 17.6% of the states has a percentage of 80% or less. Okay, so we can also get lots of information from this. The shape of this distribution is left skewed. And the reason for that is because the data is decreasing on the left side. The bulk of the data is on the right. So if the bulk of the data is on the right, we have left skewed. If it was the other way around, we would have right skewed if it was flipped. So if it's skewing, it's getting smaller and smaller to the left, then it's left skewed. We'll talk more about that in just a moment. So you want to examine the histogram, look for the overall pattern, look for any deviations, anything that looks different. Is there one peak or two peaks, then you have bimodal. Look at the shape, where's the center, where would that be? What's the variability? How spread out is it? How close together are the variables? And also see if there are any outliers. That's an extreme value that's really, really, really far to the left or really, really far out to the right. Really small values or really large values. And here's about the skewness. So the first picture here is a symmetric, has one single peak and it's symmetric. And the one in the middle is right skewed. So that's where the values are decreasing towards the right. And the values are decreasing towards the left if it's left skewed. It's really important to know that because we report this and it tells us a lot about the distribution. Okay. And we're not going to be covering stem plots. So we will skip the next 3 slides. And the final thing here is on time plots. Time, it says here a time plot shows the behavior over time. So we have these points over time, and then we connect and draw those points. We connect the dots. And time for this course is always on the horizontal axis. It's not always the case, but for this course it is. And the variable being measured is on the vertical axis. So again, we want to always look for the overall patterns and trends and deviations from the trend. Where does it change? What is happening over time? And then you want to connect the points by lines that emphasize that trend. You can see what's happening. You can look for seasonal variations and so forth. So here's plot number 1. And it is a time plot of average gauge height on the Everglades National Park monitoring station. So I have in blue, I have put a point for 2000 where it would approximately be just under 8.0. And then I've put a blue point here for 2001. So obviously there's some lines in between those 2 points. So they have also, I don't have the raw data, so there are points for each month. Looks like there's about 12 points in there, and then they've connected the dots in between. Okay, so we could just do yearly, and then we would connect these 2 dots, but because there was more data, they've added more information to the plot. But if we stand back and we look at all this, we can see that the trend is constant. It's not really increasing, not really decreasing, except for maybe this point in time on June 14 and 15 in 2011. Somehow the measurement dropped for some reason. So otherwise, it's pretty constant over time for the height. And that's all we would get from that. Still valuable if you are monitoring, the Everglades National Park information. It's valuable to them. Another one here is on the average atmospheric CO2 concentration in ppm units. So this is the time plot for that, and very meaningful for anyone who is studying the atmospheric CO2 concentrations. And we obviously can see instantly that the overall trend is increasing over time from just below, just before 1960 to just before 2020. And they have connected the dots to see that overall trend. Okay, and that concludes chapter 1.